Last lesson we were looking at how to create a noughts and crosses game. So we had something that looks a bit like this, and when we run the program we get a noughts and crosses board, and we can make moves by typing in the number of the square that we want to put our counter in. So for example, if I type number 9, then it puts an X in square number 9. If I type number 5, it puts an X in square number 5. So this is half of a noughts and crosses game, but of course the thing that's missing is the computer enemy. So we need a computer which will make the correct move to battle the opponent. Now that's what we're going to write today, and we're going to make it a little bit easier by giving the computer the first go. Okay, so the computer will need a little bit of an advantage here because it moves first. That helps to make the programming a little bit easier. If you manage to make a computer opponent which moves first and you do it all successfully, you could then have a go at making a computer opponent that moves second. It is a little bit harder, but it is the same idea. But since we're going to make the computer move first, we always have a choice of where the computer goes for the first move. And to keep it simple, I'm going to say that we always move in the very center. So the computer's first move is always going to be in square 5. So to do that in our program, what we do is we go up to square 5, which is here, and we're going to set that to O, which is the counter that the computer uses. That means that when we run our program, at the very beginning, the computer's always moved in the middle. Now the player can play in another square. So for example, I could play in the corner here. And what we want the computer to do is to respond in a suitable way. So it needs to make a move which is good depending on what the player has done. Now the way we're going to do that is by writing if statements. So we've already done some if statements here, but now we're going to write more complicated if statements which choose the best move based on the player's move. So we start off by looking at the board and deciding how the computer should respond in different situations. Let's consider a case where the player does put their X into square number 9. So I'll say if square 9 equals X. Now where would I like to go in that case? Well, I think that the center is the best square, and then the second best squares are the corners, and then the worst squares are the edges. So if the computer moves in square 9, I think probably a good move would be to go in square 3, because I could make a diagonal down there, or I could make a horizontal line across there. Of course, I can't make a vertical line down there, but there's still 2 different lines that I could make. So if the computer goes in square 9, let's make the computer go in square 3. And the way we do that is we say if S9 equals X and S3 equals 3, then S3 equals O. Now, this means if square 9 has an X in it and square 3 has a 3 in it. Now you might say, why do I need to check that? That's because remember that we have to make sure that there's not another counter in square 3. Because otherwise the computer's going to do an illegal move. It's going to put its counter on top of a square where there's already another counter. We know that's not allowed, but the computer only knows it's not allowed if you actually write it in the program, okay? Otherwise the computer wouldn't know that. So now we've written this if statement, let's test out our program. We run the program, and now I'm going to type 9. And the program hasn't worked, so I've done something wrong somewhere. What have I done wrong? S3 does equal 3. Oh, no, I haven't. Have I? Oh, I've put 2 equal signs. What a doofus. Okay, sometimes I just am so stupid I amaze myself. Anyway, let's try again. So I'll type number 9, And then there we go. So I put my x in square number 9, and then the computer put its O in square number 3. Right? Now, you can see this is a pretty good move, because now immediately the player is going to have to go in square number 7. So if the player goes in square number 7, I think the next good move could be to go in square number 2. Why is square number 2 good? Because if the player goes in square number 7, then going in square number 2 gives you 2 possible ways to win in the next turn. I could make a row across the top, or I could make a row through the center. So if player goes in square number 7, then I'm going to play square 2. Let's write that inside the program code. Now, the way that you write it in program code is, instead of using just if, we write elif. And this means we only do this thing if we couldn't do this thing. Okay, so we try this first, and if that didn't work, then we're going to try this. Now, how do I write that rule? Well, I'm saying that if square number 7 is an x, and don't forget, I have to check that this square doesn't already have something in it. So square number 2 equals 2, then square number 2 equals O. So it's the same pattern as before. I check one square here, and if both squares are what I think they are, then this is what I want to do. Okay, now let's run the program again. So if we go into square number 9, and then the computer plays here. Okay, now I've got to block it. I've got to go in square number 7. And then look, the computer's moved there. Now I'm really stuck, because if I block square number 1, the computer goes in square 8 and it's 1. And if I go in square 8, then the computer goes, oh no, hold on, if I go in square 8, I've won. So maybe that wasn't the smartest move after all, because I should go in square 8, shouldn't I? So I didn't check that carefully enough. Okay, so I better put a rule in. Okay, let's put in another rule. I'll say if S9 equals X and S7 equals X, then S8 equals O, right? So that means if there's an X here and an X here, I've got to block them. Before I do anything else, I've got to block them. Okay, otherwise you get so carried away trying to win that you forget that the other person can win before you can. So let's test it again and check that the computer is a bit smarter than I was now. So I'm going to type number 9 for my move. Now the computer moves here. Okay, I'm going to type number 7 to block the computer and also to threaten to make a line. And let's see if the computer stops me. So, okay, now the computer stops me correctly. Okay, now, in this situation, what do I have to do? Okay, well, I have to block number 2. Otherwise, the computer's going to win, right? So let's say that I move in number 2. And now we can see that at this stage, the computer only has one chance to win. And it's not very likely, to be honest. But the computer could put O here or put O here. So we could add a rule for that. And then that would probably be blocked by the user, and this game would be a draw. Okay, so we've made 3 different rules about what the computer should do in different situations, but these 3 rules just depend upon the player putting their counter in square 9, because that's what we were looking for here. How about if the player puts their counter in square 7? Well, at the moment, the computer is going to put its O up here, and that actually isn't a bad move, but it means that I put my X into square 8 because I have to block the computer making a row. And then unfortunately, the computer doesn't know what to do in this circumstance, because it should go in square 9 to block my row, but it doesn't know that it should do that. So let's write another elif statement to make sure that the computer does the correct thing. You might know how to write this elif statement now, so have a go at it yourself before I show you. Okay, and here's what the answer should be. It should say elif S7, that's square 7, equals X, and S8 that's square 8 equals x. And don't forget, we have to check that this square is empty as well. So square 9 equals 9. Then square 9 should be blocked. Right, now I've added that rule. Let's run the program again. Okay, now I'll move in 7. Now the computer moved here, so I have to block at 8. And now the computer correctly blocked my row so that I wasn't able to finish the row. Okay, now maybe I could move in square number 1, and the computer would have to block this by moving in square number 4. So that's a rule that you're going to have to write by adding another elif line to your program. Now guys, I think you can see how this works, okay? The more elif lines we add to our computer player, the smarter our computer is going to be. So what I want you guys to do is to play your game, try making different moves, and when you see that the computer player either doesn't know what to do or makes the wrong move, you need to add another elif line into your program so that the computer gets a bit smarter and it makes the correct move. Okay, the more elif lines you add, the better your computer player is going to be. Okay, so good luck everybody. I hope that you are able to produce the most amazing noughts and crosses player in the world, possibly the computer player that will become world champion. But anyway, let's not be too ambitious. Maybe just a computer player that's able to beat your mum and dad. We'll see what you can come up with.